multiple regression coefficient. So the best fit line, we can also do it for the multiple regression equation, meaning that we have more than one independent variable. So the sample regression line will be written as y hat equals to b naught. So this is the y-intercept. And now we have b1 x1 plus b2 x2 and so on until bk and xk. So previously, this one we call it as the slope coefficient. So now this is the partial slope coefficient. So this is an estimator of beta naught and this is an estimator of beta 1. The estimated partial slope coefficient beta I measures the average change in y for each change of 1 unit in x, holding other independent variables constant. So the definition is the same, only that it adds on a few words here, which is a new term, holding other independent variables constant, or ceteris paribus. So example, we are studying the consumption of chicken, and we have the independent variables, which is the income level, the price of the chicken, and price of other goods, which is the fish and also the beef. So we have data on consumption of chickens, income, price of chicken, price of fish, and also price of beef. So here is the data. You have the column Y, which is the data for the consumption of chicken, another column for X1, which is the income, X2, price of the chicken, price of fish, and also price of beef. So when you regress y on other axes, y on x1, x2, x3, and x4, using the same method, or if you are using Excel, you can always choose the data analysis menu and then choose regression, and the y is the consumption of chicken column, and then the independent variables, the x is all the x1 until x4, and you get these results. So this is the intercept, the y-intercept, and all these are the partial slope coefficient. So how do you set up the least squares regression line or the sample regression line? So from the estimation output, you can pick up 37.232 as the B naught, 0.005 as the partial slope coefficient of B1, and this is going to be B2, B3, and also B4. Interpret the partial slope coefficient, beta 2 and beta 4. Sorry, B2 and B4. So B2, the value is minus 0.611. So meaning that holding other factors constant or does not change, for each additional 1 cent per pound in real retail price of chicken, the per capita consumption of chicken is estimated to decrease by a mean of 0.611 pounds. B4 equals to 0.07. So how do you interpret? Holding other factors constant, for each additional 1 cent per pound in real retail price of beef, the per capita consumption of chickens is estimated to increase by a mean of 0.07 pounds. So you can look straight away from the result here. So you need to know what is y and what is x. So basically, how do you get minus 0.611? If you differentiate ch hat with respect to x2, you get minus 0.611. So what does this mean? Means that if 1 unit increase in x2, on average, ch will increase by, since it's a minus sign, ch will decrease by 0.611. unit, uh, ceteris paribus or other factors, which is x1, x3, and x4 remain constant. So that is the general way of interpreting this, the partial slope coefficient. But if you are using the definition for x2 and ch, then you'll get what we just what we just discussed right now, which is when we talk about 1 unit of x2 means that 1 cent per pound in real retail price of chicken. So that is the unit of it. X2 is the real retail price of chicken. So 1 unit increase in x2, one additional unit increase, one additional 1 cent per pound in real retail price of chicken. When there is an increase, on average, the CH, what is CH? CH is per capita consumption of chicken is estimated to decrease. Why is it decrease? Because we have a negative sign. So it shows an inverse relationship. One increase, another one decrease. So decrease on average or by a mean of uh, 0.611 pounds. So the units is in pounds. So meaning that 1 unit increase in X2 on average CH decrease in decrease about 0.611 unit and holding other factors constant or do not change. So how can we predict the per capita consumption of chickens when X1 is given as 500, X2 50 cents, X3 75 cents, and also X4 1.20. So what we can do is we can simply replace all the X1, X2, X3, and X4 with the value of beta B0, B1, B2, B3, and B4, and you get the CH hat, which is the estimated Y or estimated consumption of chickens, which is 32.432 pounds.